Hey everyone, in this video we are going to solve the maximum depth of binary tree question on Leetcode. So maximum depth is the longest distance between the root node to the farthest leaf node. In this case it is 3. So from 3 to 20 to 7. Also you can count from 3 to 20 to 15. This is the maximum distance from root to leaf node. So the output is 3. So let's see how we can do it. Okay, so to solve this particular question, we will be using recursion and solving the sub problems first and then the whole problem. So what do I mean by solving the sub problems first? So let's say if we have a single node which have no children in it. So the maximum depth for this node will be 1 only. Okay, so let's say we have another node which have two childrens. So in this case, what will be the depth? So for the leaf nodes, it will be 1 and 1. And for the parent node, it will be 1 plus which one is the maximum from the left child from the left subtree and the right subtree. So it will be maximum from left and right. So in this case, both are 1. So the output will be 2. So if we apply the same logic here on the sub nodes, on the leaf nodes, so for 9, the depth will be 1. Similarly for 15 and 7. But when we come to node 20, its maximum depth will be 1 plus maximum of depth of its children, which is 15 and 7. Both are 1. So it will be 1 comma 1. The output will be 2. So the maximum depth at 20 will be 2. Similarly, if we do for the root node 3, so it will be 1 plus the maximum of its left and right subtree. So on the left subtree we have only 1 and on the right subtree we have 2. So the max of 1 comma 2, so it will be 1 plus 2 3. So what we have is a kind of a formula. So the base case will be 0. If the root is null, just return 0, and the remaining part will be 1 plus maximum of which one, left and right. So whichever one is maximum, we'll add 1 to it, and by doing that we'll get the maximum depth for that particular node, and we will keep doing that for every single node, and rest recursion will handle everything. The time complexity for this one will be O of n, where n is the number of node. Space complexity is O of h, the height of the tree, because of the recursion call stack. In a worst case scenario, it can also be O of n if it is not a balanced binary tree. So let's see how we can do it in code. Okay, so first we'll write the base case for our recursive function. So if the root does not exist, we'll just return 0 from here. Otherwise, we'll return 1 plus whichever is the maximum from left and right subtree. So to calculate maximum, we'll use math.max in JavaScript, and to get the maximum from left subtree, we'll call the max depth function again and passing root.left. Similarly for root.right, we'll again recursively call max depth function and passing root.right this time. Okay, so if we run this, yeah, it's working. Let's submit this. Yeah, that's working. So that was it for this video. Thank you for watching.